This question is about two positive integers, m and n. We're interested in maximizing m plus n subject to two divisibility conditions. M divides n plus 20 and n divides m plus 25. So this big vertical line means divides. So let's translate it into language that doesn't involve the big vertical line. So some positive integer q times m is equal to n plus 20. So since n divides m plus 25, it follows that qn divides qm plus 25q. But now we've got a way of getting rid of qm. It's equal to n plus 20. So qn divides n plus 20 plus 25q. So qn divides, and I'm going to do a bit of cunning algebra here. I'm going to write n plus 45, so I've added on 25, and then I'll subtract off 25 here. Now, how can this happen? Well, there's two cases to consider, q equals 1 and q greater than 1. So let's first consider the case that q is 1. In that case, this is 0, and because qn divides this number, we get that n divides n plus 45. And therefore, n divides 45. So n is at most 45. But if you recall, we had the equation qm is n plus 20, and q is 1. So m is 20 more than n, and so we do have the possibility that m is 65 and n is 45. So these are upper bounds for both n and m in these circumstances, and then m plus n would be 110. You can check, by the way, that these two numbers work and satisfy the conditions for the problem. We don't yet know that this is the answer. Indeed, it isn't. But that's what happens. That's the best you can do when you let q be 1. So now we consider the case that q is bigger than 1. qn divides this expression, so qn is less than that expression, a weaker statement. So let's write it down. qn is less than or equal to n plus 25 q minus 1 plus 45. Now do a bit of tidying. Subtract n from both sides. And now, because q is greater than 1, q minus 1 is not 0. Indeed, it's positive. So we can divide by it. Now, this is an integer, so it is at least 2. So this expression on the right-hand side is at least So n is at most 70. So, recall that Q times M is n plus 20. We had that earlier. We've established an upper bound for n. 2m is less than or equal to qm, because q is at least 2. But qm is n plus 20. We established that earlier. And now n is less than or equal to 70. So n plus 20 is less than or equal to 90. So 2m is less than or equal to 90. So m is at most 45. So n is at most 70, m is at most 45. Look at the pair mn equals 45, 70, and just check that they satisfy the conditions of the problem. And they do. So you're done. You have found the pair mn, which maximize m plus n, and that is 45 plus 70, which is 115, which beats the record that we established when Q was 1. And so this is the overall winner, and we're done.